Name of the third unit is data sources. Online data repositories are platforms that store and share datasets which we can use for analysis, research, and building machine learning models. These repositories make it easy to access different types of data, whether it's structured like tables in a CSV file or unstructured like text. Some popular examples include Kaggle, which is widely used in data science competitions, the UCI Machine Learning Repository, which is great for academic projects, and Google Dataset Search, which helps you to find datasets across the web. Platforms like GitHub and Zenodo are used to share open source datasets, while government portals like data.gov, WHO, and IMF provide reliable public data for health, economic, and social research. There are several ways to retrieve data from online repositories depending on how the data is made available. The most common method is downloading files manually, where you simply download datasets in formats like CSV, JSON, or XML. For more dynamic access, we can use APIs which allow us to fetch real-time data, like getting tweets from Twitter using the Twitter API. Another method is web scraping, where we extract information from websites using tools such as Beautiful Soup or Scrappy. Finally, for large-scale or structured data, we often use database connections. This involves writing SQL queries to pull data from cloud services like Google BigQuery or AWS RDS. Each method has its own use case, and learning them helps us work with a wide range of data sources effectively. Scrapping is the process of automatically extracting information from websites instead of copying data manually from a web page. Web scraping tools can collect large amounts of data quickly and efficiently, which is useful for analysis, research, or even automating repetitive tasks. Here's how it works. First, a request is sent to the website server, often using tools like Python's request library. The server responds by sending back the HTML content of the web page. Next, we parse this HTML to find and extract the specific data we are interested in. This is usually done with tools like Beautiful Soup. Finally, the extracted data is stored in a format like CSV, JSON, or even in a database, so it can be analyzed or used in applications later. Web scraping is a powerful skill for anyone working with online data. When working with real-world datasets, we often encounter what's called messy data. This means the data may have errors, missing values, duplicates, or inconsistent formats. And if we don't clean it first, any analysis we do can be misleading or completely wrong. Some common problems include missing values like empty fields in a dataset. For example, someone's age might not be recorded. We might also find duplicate entries where the same record appears more than once. Inconsistent formatting is another issue, like writing New York in one row and NY in another. Sometimes data is stored in the wrong format, such as an age being stored as text instead of a number. We may also have to deal with outliers, which are unusually high or low values that can skew our results, like a salary listed as $1 million when most others are 50,000. Finally, special characters in text such as hashtags or symbols can make names or words unreadable. Cleaning all of this up is a critical step before doing any serious data analysis. Once we identify messy data, we need to clean it using the right techniques to make sure our analysis is accurate and meaningful. One important step is removing duplicates, which ensures that each data entry is unique and not repeated. We also need to deal with missing values. This can be done by filling them in with the average, median, or a default value depending on the context. Another key task in standardizing formats, for example, making sure all dates follow the same format or that abbreviations like NY and New York are used consistently. Sometimes data is stored in the wrong format, so we convert the data types like changing a column of numbers that were saved as text into real numeric values. It's also important to remove special characters that don't belong, like symbols in names or product descriptions. Finally, we must deal with outliers, extreme values that can distort our results by identifying them and deciding whether to correct or remove them. All these steps are part of the data cleaning process, which is essential before moving on to any serious analysis. When analyzing data, one common challenge we face is dealing with messy data types. This happens when information is stored in the wrong or inconsistent format. These problems lead to errors or incorrect results if not fixed. For example, data formats may vary, such as one row showing 12/03/2023 and another showing March 12, 2023. To analyze data properly, we need to standardize all formats to one consistent style. Another issue is numeric data stored as text, like number 1000 being stored as a string rather than a number, which must be converted before calculations can be performed. Similarly, categorical data may have inconsistent entries like male, M, or lowercase m, all meaning the same. We should standardize these entries for accurate grouping and filtering. Finally, unstructured text data, such as open-ended survey responses, is harder to analyze using basic tools. In such cases, we use techniques like natural language processing to extract meaning and patterns from the text. Cleaning these data types is a crucial step to make them usable for any kind of meaningful analysis. Effectively, with messy data types, we need to apply specific methods that transform the data into clean, consistent format. One important technique is converting text into numbers, especially when numeric values are mistakenly stored as text. This ensures we can perform calculations or analysis correctly. We also need to standardize formats, date formats so that all date entries follow the same structure, avoiding confusion and errors during sorting or filtering. For categorical data like gender or location, we must ensure all labels are consistent. For example, changing all versions of male, capital M and M into one uniform category. Finally, handling text data such as survey responses or descriptions, it's important to clean up inconsistencies, remove unnecessary special characters, and prepare the text for analysis. These steps help to transform messy data types into clean, usable formats for accurate analysis and interpretation. Working with real-world data, missing values are very common and can cause problems if not handled properly. One simple way to deal with missing data is called complete case analysis, where we simply remove any row that has a missing value. This method is easy to use and avoids guessing or filling in missing values, but it can make your dataset much smaller and can cause bias if the missing data isn't random. Another basic approach is to fill in missing values with mean, median, or mode of the available data. This keeps the dataset size the same but can reduce natural variation in the data. Sometimes missing values are replaced with a constant number or a special category, especially if the fact that data is missing might carry some meaning. Lastly, for data collected over time, a missing value can be replaced by the last recorded value, assuming things haven't changed much. These methods are simple and quick but might not always give the most accurate results, so they are best used when missing data is small or when you need a fast fix for early analysis. Manipulation is another way to handle missing data that is a bit more flexible than removing entire rows. Instead of throwing out a whole row if it has any missing values, this method only ignores the missing parts when calculating things like correlations or regressions and keeps the rest of the available data. This means we can use more of our data compared to complete case analysis, which can improve results. However, since different parts of the analysis might be based on different amounts of data, this can sometimes cause confusion or inconsistent results. Pairwise deletion works best when missing data happens randomly and is often used when we want to understand relationships between variables, like in correlation or covariance studies. Mean substitution is a simple way to fill missing data by replacing the missing value with the average, that is mean, of the existing values for that variable. This method is easy to do and keeps all the data points in the dataset, which is helpful when you want to keep the sample size the same. However, using the mean to fill in missing data can reduce the natural variation in the data and may give biased results because it makes different data points look more similar than they really are. It can also affect how variables relate to each other. Mean substitution is best used only when there are few missing values and the data is fairly normally distributed without extreme outliers. Hot deck imputation is a method where missing values are filled in using values from other similar cases within the same dataset. For example, if someone's salary is missing, we might use the salary of another person who has similar characteristics like age, gender, or job type. This way, the data keeps its natural variation and the relationships between variables stay more accurate compared to just using averages. However, choosing which cases to copy from can sometimes be tricky and might introduce bias if the wrong donor is selected. Hot deck imputation works well when missing data is related to certain groups or patterns in the data, such as replacing missing salaries with salaries from the people in the same profession. Imputation fills in missing values by predicting them using a regression model based on other related variables in the dataset. For example, if someone's income is missing, we might predict it using information like their education level and job title. This method takes advantage of the relationships between variables to provide better estimates than just using averages. However, it can reduce the natural variation in the data and might overfit the model if not careful. It also assumes that these relationships are linear, which might not always be true. Regression imputation is best used when there are strong connections between variables and when there is a moderate amount of missing data, usually between 5% and 20%. Regression imputation is an improved version of regular regression imputation. It predicts missing values using a regression model like before, but then adds a small random error to the predicted values. This helps keep the natural variability in the data, making the filled in values more realistic. While this method is usually more accurate than simple regression imputation, it requires careful handling to avoid introducing bias and is a bit more complex to perform. It is best used when there are clear relationships between variables and when you want to preserve the natural randomness in the data. Multiple imputation is a more advanced method for handling missing data when, instead of filling in missing values just once, it creates several different versions of the dataset with different possible values for the missing parts. These multiple datasets are then combined to get a final, more reliable result. This method captures the uncertainty around the missing values better than single imputation methods, leading to more accurate and less biased analysis. However, it can be complicated and requires more computing power and special software. Multiple imputation is especially useful when a significant portion of data is missing between 10% and 50% and when high accuracy is needed, such as in medical or scientific studies. Sanitized data is a data that has been carefully cleaned and checked to make sure it is accurate, consistent, and ready for analysis. This process includes fixing errors, handling missing information, and making sure all data fits the right formats and rules. Sanitizing data is important because it helps to ensure that any models or reports were created we create from the data are reliable and trustworthy. One key step in this process is checking for out of bounds values, which are data points that fall outside the expected range. These unusual values often happen because of mistakes like wrong data entry or problems during data processing, so finding and fixing them helps improve data quality. Out-of-bound values are data points that fall outside the range of what is considered normal or possible. For example, an age recorded as -5 of 150 years is not realistic since human age should be between 0 and 120 years. Similarly, a salary of 5,000 when the expected range is 10,000 to 2 lakh, or a temperature of 200 degrees Celsius when it should be between -50 Celsius and 60 degrees Celsius are clear examples of out-of-bound values. To handle these errors, we can set valid ranges to automatically detect such values and then either remove or correct them. One common way to fix them is by replacing the incorrect value with the average, mean or median of the valid data. It is also important to use domain knowledge like knowing that a person cannot be 200 years old to decide what makes sense to fix or to remove. Data type validation is the process of making sure that data is stored in the correct format, because having the wrong format can cause mistakes during calculations or analysis. For example, if age should be a number like 25 but it is written as the word 25, it can't be used in math operations. Another example is a date like 31/02/2023, which is invalid because February cannot have 31 days. Sometimes Boolean fields that should say yes or no might have misspellings like YESS. To fix these problems, we convert data into the correct type, such as turning text into numbers, and use special functions to check if dates are valid before using them. This step helps keep data clean and useful. Categorical data is made up of specific groups or categories, like gender being male, female, or other. Sometimes unexpected or misspelled values like MLE or FEMAIL appear, which can cause problems during analysis. For example, a status field might have categories like completed, pending, and cancel, but you might find values like COMPLTD or in progress that don't fit. To handle these issues, it's helpful to use drop-down menus or preset options when collecting data, so only valid categories can be chosen. We can also clean the data by correcting misspellings, turning MLE to MALE, or by grouping similar categories like merging in progress with pending. This helps to keep the data consistent and easier to analyze. Outliers are values in a data set that are very different from the rest of the data. These extreme values can sometimes cause problems in analysis because they might distort results. To find outliers, we can use methods like z-score, where any value more than 3 standard deviations away from the average is considered as an outlier. Another common method is interquartile range IQR, which flags values that fall far below or above most of the data. We can also use box plots, which are graphs that show outliers visually. Once outliers are identified, it's important to check why they exist, whether they are data entry mistakes or real unusual cases. We can handle them by either capping their values within reasonable limits, or by using more robust statistics like the median, which are less affected by outliers than the average. Typographical errors happen when someone makes a mistake while typing data, which can affect both text and numbers. For example, John Doe might be typed as JHONDEO, or New York appear as NEWYRK. Even simple answers like yes or no can be misspelled as YSS or NPO. To find these errors, we can use special tools called string similarity algorithms that detect words that look alike but are spelled differently. We can also use spell checkers or limit answers to predefined lists of categories. Additionally, cleaning the text by converting everything to lowercase or removing unnecessary characters help make the data consistent and easier to fix. Data refers to values that could be possible but are very rare or unrealistic in real life. For example, a height of 250 cm over 8 feet for an average adult is highly unusual for or a monthly salary of just rupees 1 for a working professional doesn't make sense. Similarly, a date of birth like 1890 is very unlikely for someone alive today. To handle such data, we compare values against real-world ranges like typical height or salary levels. We can also check against official sources to verify if the numbers make sense. If values seem suspicious, they should be flagged for manual review to decide if they need correction or removal before using the data for analysis. To find outliers using the IQR method, we first arrange the data in order. For the given example, we get the order as 45, 50, 55, 60, 65, 70, 75, 80, 150 and 200. This is step 1. Then we find the first quartile Q1, which is the middle value of the lower half of the data, and it is 55. Next, we find the third quartile, that is the middle value of the upper half, which is 80. The interquartile range IQR is the difference between Q3 and Q1. So 80 minus 55 equals 25. To find the limits for outliers, we calculate the lower bound as Q1 minus 1.5 times the IQR. That is 55 minus 37.5, which is 17.5. And the upper bound as Q3 plus 1.5 times the IQR, which is 80 plus 37.5, which is 117.5. Any data point below 17.5 or above 117.5 is considered as an outlier. In this case, the scores 150 and 200 are above the upper limit, so they are considered as outliers in the dataset. This is how the outliers are computed using the IQR technique. Thank you.